This is an international team with people from Europe as well. So basically, we are working on an ECoG task. So essentially, it's a three-class hand gestures classification task. So 3 hand gestures: fist, peace sign, and open, also known as rock, paper, scissors. So we have our data acquisition paradigm essentially involves a 2-second task with 2 to 3 seconds of rest in between. And it contains a balanced data set of 30 trials per class. So of a total of 90 trials. Yeah. So that's our ECoG data set. It's taken from subject 2 from the original paper that was published. And the data is sampled at a frequency of 1200 Hertz, consisting of 59 ECoG channels. And it's recorded from the right motor sensory cortex, as shown in the picture on the right. And so the next few slides are just our pre-processing steps. So the pre-processing steps involve the following pipeline. So we re-reference the data by the common average reference. And we also perform the notch filter, which involves elimination of the power line signals from 50 Hertz in steps of 50, so 50, 100, 150, 200, and so on, up to 300 Hertz. And following that, we apply a bandpass filter from 50 to 300 Hertz, as well as a spectral whitening filter of the order 10. And finally, we segmented the data in epochs of 2 seconds. And we have 2 approaches, which I will then go on to present. So the first one, we use a RIEMANN approach using a Riemannian geometry. So essentially, just to keep it simple, we from each epoch, we extracted a covariance matrix, which can be represented on a Riemann manifold, as you can see on the picture on the bottom right. But however, in order to apply the classical machine learning algorithms, we have to project these Riemannian sort of features back into a Euclidean space, a flat space. And this is known as a tangent space. And finally, the last step, we use logistic regression with elastic net penalty and L1 ratio of 0.15. So these parameters are decided after hyperparameter tuning, which I will not present here. So that's our approach number 1. We'll show the results later on. So before that, I'll just move on to our second method, which we have decided on, which is the sliding window approach, and as well as support vector classifier. So in this method, instead of dividing the data into epochs, we use sliding windows of 10 seconds window length, sliding every 0.1 seconds. And this is a kind of data augmentation where we try to upsample from the data provided to us. The features that we extracted from these each window included the mean, the variance, the standard deviation, as well as the percentiles. So coming to 7 features for all the 59 channels. And with all these 7 features, we use a support vector machine to perform the classification task. And of course, before we came to all these 2 approaches, we have tried on a number of other algorithms, such as KNN and naive-based classifier, and so on and so forth. Of course, the linear discriminant analysis classifier. So these are the results we obtained. I think the accuracy are quite high for both approaches. The Riemann approach achieved accuracy of 97%, and you can see the confusion matrix below. Whereas for the sliding window, we achieve an accuracy of 99%, which is comparable to the time variant LDA that was presented in the original paper. So I think that's quite good results, and these are based on tenfold cross validation. So I think the results are pretty robust. And of course, these results are based on just one subject, so I'm not sure how generalizable these algorithms are. So if given more data, we would like to test it on more subjects. And I think that concludes my presentation.